So what is meant by coherent scattering? Coherent scattering means the wavelength of the scattered light is same as that of the wavelength of the incident light. There is a normal eye has got 576 megapixels of the clarity. Myopia means short-sightedness. Hypermetropia means it is long-sightedness. So what can be the defects of eye? It is hypermetropia and myopia. That is the short-sightedness and the long-sightedness. Hello everyone, I am Randa, Faculty of Physics from Vidhyaashram Pre-University College, welcoming you all to Session 7 of Chapter 9, Ray Optics and Optical Instruments. So in today's class, we are going to check regarding the optical instruments. That means we are talking something about the eyes. The whole session is all about the eyes. So here, there is a concept called as a scattering of light. So what is meant by that scattering? Scattering means as the light passes through any of the optical medium, what happens? It disperses itself. Correct? Dispersion of the light into different paths is said to be the scattering of light. So in scattering of light, there are two types of scattering. That is, one is coherent scattering and another one is incoherent scattering. So here why it is called as coherent scattering and incoherent scattering? So as and when the light scatters, sometimes the wavelength is similar, that is the wavelength of the scattered light is similar to that of the wavelength of the incident light. In some other cases, the wavelength of the scattered light is actually too very different from that of the wavelength of the incident light. So by having these concepts, by experimental observation of certain things, gave the existence of two types of scattering, and that is coherent scattering and another one is incoherent scattering. So what is meant by coherent scattering? Coherent scattering means the wavelength of the scattered light is same as that of the wavelength of the incident light. Similar way it goes for the incoherent scattering. That means the wavelength of the scattered light is said to be too very different from the wavelength of the incident light. So what is said to be coherent scattering? Coherent scattering means the wavelength, this is the wavelength of scattered light is same as that of incident light, and in case of incoherent scattering we have the wavelength of scattered light is different from that of incident light. So we have two sets, coherent scattering, incoherent scattering. So for coherent scattering, we can give this as Rayleigh scattering. Rayleigh scattering. And for incoherent scattering, we can give it as Raman scattering. So we have Rayleigh scattering as an example for coherent scattering, and for incoherent scattering we have the example as Raman scattering. So in case of coherent scattering, we can just check into the Rayleigh scattering. It is like the same set of wavelength is occurring which is same as that of the incident light. So when this is the case, there is an example why sky is blue in color. Why the sky is blue in color? And that is because we consider the sun. Sun is a light which is consisting of white light, and within it has got the 7 constituent colors. As and when it passes through the different atmospheric layer, what happens to the 7 constituent colors? It just gets refracted. When it gets refracted, what happens in the sense, the light which is having a shorter wavelength scatters the most. The one which is having a longer wavelength doesn't scatter at all. It has got an intense beam. But the one with the shorter wavelength in case of Vidhyaashram is blue. So when that is the case, blue scatters the most in the atmosphere, because of which the sky looks blue in color. Okay, this is how the Rayleigh scattering was explained. And now we have got the optical instruments. So according to this optical instruments, we have an eye. Eye is a natural optical instrument. So when that is the case, you have an anatomy of eye over here, wherein you can see the iris, pupil and sclera. Okay, and you have the complete structure of the eye, wherein you have got your retina, that is this yellow part what is there, that is called as retina, which is mentioned over here in this name, retina. And the nerve which you can see over here, this is called as the optic one. Okay, this yellow color tube like structure at the end along with the nerve is called as a optic nerve. So we have an eye, and eye is having a main part called as lens, and the lens what is present in eye can be called as biconvex lens. Okay, which has the clarity more than that of any of the camera, that is its clarity is 576 megapixels. Okay, a natural eye, that is a normal eye, has got 576 megapixels of the clarity. Clear with that? Okay, so now there is a retina in this and lens which is having certain megapixels, because of which the clarity of whatever you view will be too very great. Okay, the eye lens is actually held up with the iris. So this part is called as iris. Okay, and then we have a pupil which is present over here. Okay, these are the ones about the eyes. Okay, so which are the main parts of eyes? One is retina, one is optic nerve, one is lens, that is biconvex lens, iris, pupil and cornea. Okay, so now as and when the light passes, how exactly we can visualize the image? We can visualize the image by our eyes, and that is how? By the reflection which is taking place. Okay, so the light from the natural source, and that is the sun. From there the light enters and falls onto any of the object, because of which we can look into our eyes. It gets reflected into our eyes and we can observe the image. How is that? Through which part we can observe the image, and how is that we will get to know this is the same object what we are observing? If suppose a light falls on a tree and I observe tree, okay, tree is brown in color, green in color, so it is a tree, it is an apple, it is a human being, it is a vehicle. How is that I can visualize or differentiate among the objects? And that is all because of the retina as well as the optic nerve. Whenever you just keep your lens straight focused on any of the object whichever you want to see, natural source or any of the light which passes through the object, it gets reflected into our eyes through this biconvex lens, and it straight away it moves to the retina and it meets at the retina at this point. Okay, so when it meets at that point, what happens? We'll get to know the messages which is formed, that is the electrical signals, are being sent to the optic nerve, which later on is accepted by the brain, and brain gives the, oh, this is this image what you have observed. Okay, this is how we will get to know what we are observing and what is the color. In order to check out the intensity of the light as well as color, we have some special organs within this, that is rods and cones. Okay, these are the special part of the eye. Rods, the one which senses the intensity of the light, and cones are the one which senses the color. Okay, color of the object or color of the light. These are the ones like how the eye functions. Clear with that? Okay, so having all these, that is our eye is a beautiful gift because of which we can visualize things. So we know how exactly we can visualize the objects. And finally we have accommodating power, okay, or it is also called as accommodation. So what is it? Accommodating power or accommodation? It is the ability of an eye to visualize the object at various distances. Okay, it is the ability of our eyes in order to visualize any distance objects by our eyes. Okay, so what is it? It is like automatically our eye changes its focal, it adjusts itself in order to observe the image. So that power is called as accommodation or accommodating power. So in case of retina, we have two different types. One is blind spot and another one is yellow spot. So what is blind spot and what is yellow spot? So blind spot is the place where the sensitivity is very low on retina, okay? It is least sensitive part of the retina, which is called as blind spot, where exactly the things are not clearly visible. Clear? And what is meant by yellow spot? It is the one which is having a maximum vision, okay? This is nothing but this yellow spot is a spot, the sensitivity is maximum in this case. So whichever falls on this yellow spot, we are able to visualize things. Clear with that? So retina consists of two spots, blind spot and yellow spot. So that is all about your eyes, and now we are going to defect of eye. So what can be the defects of eye? It is hypermetropia and myopia. That is the short-sightedness and the long-sightedness which actually we go through in our lives, okay? So that is maybe due to over looking into the televisions, mobiles or systems or anything, over burdening your eyes, stressing your eyes. Because of all these, we will face this kind of defects. So now we have got myopia. We are talking about short-sightedness. Short-sightedness means we can see the shorter distance, least distance things, okay? So can you please think on it, what might be the shortest distance, that is a minimum distance for an eye to visualize things? That is 25 centimeters. 25 centimeters is the minimum distance to which the object can be observed by our eyes or sensed by our eyes, okay? So we have short-sightedness now. That means any ray of light which is passing through the least distance, it easily falls onto the retina, okay? Suppose if the object is too very far, is it visible? No. Okay, shorter distance object are clearly visible by the eye because it is short-sightedness. The objects which occupy the largest distance, light from that larger distance will never fall on the retina. That is, for a normal eye, in this case you have, this is a normal eye. So whichever light comes from here, if this is the eye lens, whichever light comes from here will clearly fall onto the retina. It falls onto the retina over here, because of which it is visible. So this is a normal eye, okay? For a myopic eye, okay, the one who is suffering from myopia, that means short-sightedness, what happens if suppose this is an eye and here there is a lens, any light which is coming from far, it tends to meet at certain point where that is before the retina. So you have a gap of certain distance, okay? So it meets at certain focus and the focus is not on retina. When this is a case, it is told that the light which comes from the farther objects, it comes and falls before the retina, and the light which comes from the nearer object will come and fall on to the retina. So it is called as myopic. That means it is short-sightedness and not long-sightedness. So this is called as a myopic eye. How can this myopia be corrected? This can be corrected by using a lens. And which lens is that what you use? It is the concave lens. So when the concave lens is used, if suppose this is your eye, when the concave lens is used, all the light which comes over here, it diverges and then starts converging at certain point, and that point is on the retina. So that is all about the myopic eyes. And next we are going on to hypometropia. So what is hypometropia? It is opposite of the short-sightedness. That means the farther distance objects are clearly visible but the nearer objects are not visible. So any light which comes from the nearer object, what happens to it? All of it, if suppose this is an eye lens, all of it goes and falls behind the retina. It falls behind the retina. It doesn't fall on the retina, because of which it has to be corrected. And the correction of lens is by using a biconvex lens. There you are using biconcave lens, here you are using biconvex lens. So what happens? The light, when it passes through the biconvex lens, it comes and meets on the retina itself. So any light which is passing from the shorter distance are not visible. For the light rays which is falling onto the eye lens will pass and it will fall exactly behind the retina in case of hypometropia. So myopia means the light rays which are visible, it comes and falls before retina, and hypometropia, it falls after retina. But in this case, short-sighted means the nearer distance objects are clearly visible. Hypometropia means the longer distance objects are clearly visible. That is all about your short-sightedness as well as long-sightedness, that is myopia and hypometropia. After this, we have got astigmatism. So as you can see in this image, you can see the normal eye as well as the astigmatism point. So for a normal eye, the light rays which is coming from either farther distance or the nearer distance, if it is normal, the light falls on the retina. So you can see this yellow color over here. So this is one focal point. That means it has got only one focal point, okay? For a normal eye, it has got only one focal point. But in case of astigmatism, it has got n number of focal points, because of which the vision looks blurred, okay? We get the multiple images of the same objects itself when you just look into things. So here again, what happens to the cornea, because of which the cornea here is a spear shape. It's a proper shape, but here the cornea gets damaged by rubbing. You keep on rubbing your eyes. What happens during the rubbing of the eyes? The cornea gets damaged, because of which we tell don't rub your eyes. Your eyesight will get spoiled. And what is that spoilage? That term is called nothing but the astigmatism. When you keep on rubbing your eye, your cornea gets damaged and the cornea gets the shape of this, that is a ovular shape, that is oval shape, okay? Because of which there will be n number of focal points. We can see here multiple points, here one and here one. So these are the focal points which is present over here. That is all about astigmatism. So in this type of defect, what is that we can do? We can just check on to the spectacles and we can use those spectacles, okay? So which lens that spectacles use, that is concave or convex lens. Either of the two can be used for this astigmatism according to one's eyesight. So in case of astigmatism, what are the disadvantages or the drawbacks what a person experience? And that is nothing but headache, blurred vision. During night times a person cannot see properly, the strain which is given to eyes, because of which the head starts aching more and more. So these are the conditions for astigmatism. And finally we are getting on to presbyopia. So what is presbyopia? It is called as a old sight, okay? What is meant by old sight? The old people having sight? Yes, it is. That means as you grow older and older, I told you the eye lens is held tightly by a iris, correct? The muscle like a structure. That muscle like a structure goes on decreasing. That is the strength of it goes on decreasing, because of which your eye, that is this, if suppose this is a normal eye, you can see all three A's over here. What happens to this eye? The muscle layer gets weakened. Because of the weakness of the muscle layer, what happens? The presbyopic eye occurs. That means the objects appear to be blurred, okay? Out of too many objects, one or two or three appears to be blurred. You get the complete blurred vision of it, okay? So that is all about your presbyopia, because of the weakening of the muscles which holds the lens. Clear with that? So now it's supposed to say that the figure which is closer appears to be blurry. That is all about your presbyopia. So in today's session, we have studied about the optical instruments as well as scattering of light. And optical instrument, in the sense, it is a natural optical lens, that is the eye lens. And finally, we have studied what are the defects of eyes, okay? So we have hypermetropia, myopia, astigmatism and presbyopia, and what is the lens which is used in order to correct these defects, okay? So that is all about today's session. Let us all meet in our next upcoming class, the same chapter. Until then, have a good day. Thank you.